Hi grade 11s, we're on to our third topic, which is our second type of pattern. Now this is the whole point of grade 11 patterns. So this is what we must write probably our best notes on, simply because in grade 12 this is examinable and every single grade 12 paper has at least one question on a quadratic pattern, and we don't really redo them in matric. So it's really important that we write good notes that you can study from next year as well. Now I've decided to split quadratic patterns into two subtopics in two different videos, and this video is basically just going to be on the basic quadratic formula. So basic questions, there's only 5 examples, then we'll practice those basic questions before we look at some tougher examples. So my first subheading is 3.1, the basic quadratic formula. So some sequences, as I've written there, are not linear in nature. So they don't have an equation that depends on n. For example, a sequence could be quadratic. Now we know from quadratic equations that that would mean that the formula is going to have an n squared in it. It could also have an n, but it must have an n squared to be quadratic. So our first example is where I've given you a sequence formula, which is 2n squared plus n minus 3. So this is definitely quadratic in nature because it's got an n squared in its formula. So let's look at the questions. Question A, write down the first 4 terms of the sequence. Now, especially in this video, don't forget to put pause whenever you need to be able to write down the questions so that you have comprehensive notes. So write down the first 4 terms of the sequence. Well, this isn't difficult. We've done this before. T1 will be when n is 1. So a little bit more difficult to calculate. But in this case, 2 times 1 is 2 plus 1 is 3, 3 minus 3 is 0. T2 would be equal to 2 times 2 squared plus 2 minus 3. Now I would normally just use my calculator, and I think I get 7. Right, let's move on. I'm going to go next door here. T3 is 2 times 3 squared plus 3 minus 3, and that gives me 18. And then my fourth term is equal to 2 times 4 squared plus 4 minus 1. And I think that gives me 31. Oh, not too sure I wrote minus 1 when I should have written minus 3. Now that changes my answer, so it's not 31, it's 33. Great, so there's my first 4 terms of my sequence, and I'd absolutely use a calculator. Now, what I'm trying to show you here and develop through this is how do we tell that something's a quadratic pattern if we don't have the formula. So this is what question B says. It says, can you determine the differences, as in the first differences? Now we've done that before. So if I just write out my terms T1, T2, T3, T4, we did this in a linear pattern because we noticed in a linear pattern that the first differences were equal. So I'm not really expecting these first differences to be equal, simply because this isn't a linear pattern. So 7 take away 0 is 7, 18 take away 7 is 11, 33 take away 18 is 15. So notice my first differences aren't equal. Again, makes complete sense because this isn't a linear pattern. Now question C says, can we work out the differences between our first differences? So far we've got our sequence, which is 0, 7, 18, 33, and we worked out our first differences, which was 7, 11, and 15. And now it says, can you work out the second difference, which is a difference of the differences? So 11 minus 7 is 4, 15 minus 11 is 4, and what do you notice? If a sequence is quadratic, what do we note about the second difference? The second difference is constant. So this kind of is forming quite a nice pattern, because if it's a linear pattern, the first difference is constant. If it's a quadratic pattern, the second difference is constant. So if it's actually a cubic pattern, your third difference is a constant. So it's pretty cool. So example 1 was just meant to show us this. If a pattern is quadratic, it has an n squared in the formula, and its second difference is a constant. Now, in the linear examples, this first difference was constant in a linear example, and it landed up being the coefficient of n. Now, you'll notice that doesn't happen here. because my formula doesn't have a 4 anywhere in it. So the question is, how are we going to find this formula? And that's example number 2. How are we going to be able to work out a formula for a general term of a quadratic sequence? Now, the general form of any quadratic sequence is Tn is an squared plus bn plus c. Now, I think the most confusing thing is a in a linear pattern meant the first term, whereas in a quadratic pattern, it's not the first term. The only reason that a is there is that normally when we did quadratic equations, we said ax squared plus bx plus c. When we did parabolas, we said ax squared plus bx plus c. And so that's why we continue to use a here. But it doesn't mean the first term because this isn't a linear pattern. Okay, so how are we going to work this out? There are 2 methods. I'm going to show you both methods. There's the easy method and then there's the more tricky method. And so we're actually going to use the easy method whenever we do our examples. So let's have a look. What is T1? Let me just move this over a bit. Okay, what is T1? T1 would be if I took this formula and I substituted n as 1. So it would be a times 1 squared plus b times 1 plus c. Now that would simplify to a plus b plus c. So that's term number 1. What would term number 2 be? Term number 2 would be when we said a times 2 squared plus b times 2 plus c. So an expression for term 2 would be 4a plus 2b plus c. Now I don't know a and b and c, so I can't actually find out these values. What would the third term be in this pattern? This would be a times 3 squared plus b times 3 plus c. So our third term would be 9a plus 3b plus c. And our fourth term would be a times 4 squared plus b times 4 plus c. So that would be 16a plus 4b plus c. So if I just took this exactly like I did with the linear pattern where we said a and then a plus d and then a plus 2d, I'm doing the same thing here. It's just a lot more complicated. So an expression for my first, second, third and fourth term are here. Now I don't know a, b and c, so I'm trying to figure out how I could figure them out. Now most importantly, with a linear pattern, the first difference is constant. With a quadratic pattern, my second difference is constant. So my question is, can I figure out these first differences? So in green, I'm going to work out what is my first difference. Now what I'm going to do here is I'm going to say, right, I've got 4a plus 2b plus c, and I'm subtracting a, b and c. So if I do 4a take away a, I get 3a. If I say 2b take away b, I can get b, and c take away c gives me nothing. Now I'm going to do that again. I'm going to say 9a take away 4a is 5a. 3b take away 2b is b. C take away c, nothing. 16a take away 9a is 7a. 4b take away 3b is b. So those would be expressions for my first differences. Now I don't really care about my first difference. What I do care about is my second difference, because my second difference should be a constant. So in order to work out my second difference, 5a take away 3a, 2a, b take away b, nothing. 7a take away 5a, 2a, b take away b, nothing. And this picture here is how we're going to find out our equations in examples, because notice that my second difference equals 2a. So if I can work out my second difference, it means that I can figure out what the a is, the coefficient of n squared. So my second difference is always going to equal to 2a. So if I scroll up to my previous example to show you, my second difference was 4. So this means 2 times a is going to give me 4. So if I divide by 2, I should get that a is 2. Now if I go and look at the example given, a was equal to 2. So the idea is if I can work out my second difference is always going to equal 2a. And so it means that I can solve for a. So that's going to be our first step. My second difference equals 2a. Now, the kind of cheating method is the fact that if you look at this, now I'm afraid my brain doesn't have space to remember all this stuff, so I always do the other method. But this is a really, really useful method. My first difference. So not any of the first differences, because remember the first differences aren't constant here, but my first difference is equal to 3a plus b. Now because you would have been able to figure out a from the second difference, you can now figure out b. So again, let me go back to my previous question and show you. What we're saying is this is your first difference. So this will be equal to 3a plus b always. So 3a plus b will equal 7. Now we would have figured out that a is 2. So 3 times 2 plus b gives me 7. So that's 6 plus b gives me 7. And b would be equal to 1. Now let's go check. Yes, it is. There's b is equal to 1. Okay, so far we have a method to work out a and b. So now the question is, what is c? Now c is going to come from here. My first term of my sequence, my first term, will always equal a plus b plus c, because n would have been 1. So every single first term equals a plus b plus c. And now if you figured out a through the first step and you figured out b through the second step, it means that you only have c unknown. So again, let me scroll up to look at our previous example. What we're saying here then is that a plus b plus c in this example would give me 0. Now I knew that a was 2. I figured out b was 1. And so I actually get 3 plus c is 0. So I get c is minus 3. And if I scroll up to, let me check, yes, it was. So you never have to remember how we get to these shortcuts. So this method that I've shown you is really important for you to see where these shortcuts come from. Ultimately, all that really matters is this is our method that I'm circling in this little cloud. Step 1, 2, 3. You don't have to know where it comes from, but it is the shortcut method, and so it's really nice and quick and simple. First you find A, then you find B, then you find C. Now when we do an example, I will show you a second way to do it, simply because if you forget this, it's nice to have a backup. I must say I have really struggled to remember these half the time. Okay, so let's look at an example where we're going to use this. This question says, consider the quadratic equation, the quadratic sequence 5, 9, 19, 35, determine a formula for Tn. Now if they hadn't told me it was quadratic, I could have checked. So let's check. What's my first difference? That's 4. This is 10. And this is 16. Now I wasn't expecting a constant first difference because it's quadratic. So what's my second difference? My second difference is 6 and 6. And what do you know? It's a constant second difference, which means it's quadratic, which I had known in the first place. So if I didn't get a constant second difference, I've definitely made a mistake. Okay, now I can find a, b, and c in my formula. So my formula would be Tn equals a n squared plus bn plus c. And I can find these 3a, b, and c by following my kind of formula, my steps. First step is 2a equals my second difference. So in this particular example, my second difference was 6. So 2a must equal 6. Therefore, if I divide by 2, I get a is 3. So I immediately know that in my formula, a is 3. So that's my first step. My second step is this first difference is equal to 3a plus b. Now that's something you're going to have to memorize. As I say, I struggle to remember it, and so the moment that you get into an exam or test, you might actually want to write that down. So 3a plus b equals your first difference. So in this case, 3a plus b would have to equal 4. Now I've already found out the value of a. It's 3. So if I go and substitute it in, now let me just draw myself an arrow here so I know where that came from, because when you're studying in a year's time, you're going to be confused as to where that came from. So 3 times 3 is 9. 9 plus b is 4. And so b is equal to negative 5. So now I know b is negative 5. So my third step is simply, how do I find c? And how do I find c is this idea that this first term is equal to a plus b plus c. So I now know that a plus b plus c is equal to my first term. Now a was 3, b was negative 5, and I don't know c, but my first term is 5. So I'm afraid I've run out of space, so I'm just going to go over here. So that's 3 take away 5, which is negative 2 plus c is 5. So if I add 2 to both sides, I get 7. And so I know this is 7. So can I find the general formula? Absolutely, I just have. I know that Tn equals 3n squared minus 5n plus 7. Now, I always check if I'm right, because I often make silly mistakes every now and again. So to check if I'm right, all I'm going to do is sub in n as 1 and check, do I get 5? And then I'll sub n as 2 and check if I get 9. And fortunately, I do get that in this case, so I know I'm right. So just use your calculator quickly to check maybe the first 2. It kind of gives you a bit of comfort to know you're right. So those are my 3 steps. The problem with this method is you've got to remember those, but I suppose you have to know how to begin. So those 3 steps gets us straight to A, B, and C. Now, how do I do the second method? Now, I'm going to show you the second method, and if it's something that makes sense to you, I'd probably write it down and go, that's nice. But if it's not something that you like, most of the time, we can just use our cheat. So let me just erase everything so I can start again. Right, so I've just erased everything so I don't run out of space, and I'm going to show you method 2. Now, the only time you need method 2 is what happens if they don't give you the first term? What happens if they gave you term number 100, term number 101, and term number 102? Now, the chances of this ever happening are minimal, so method 1 works 99.9% of the time. So how does method 2 work? Well, method 2 has the same first step, the fact that the second difference is 2a. So 2a would equal 6, and so a would equal 3. Now, I don't know b and I don't know c. So far, I know that this question is 3n squared plus I don't know b and I don't know c. Now, it's actually a fairly simple method and one you've been doing for ages. It's simultaneous equations, because if you have 2 unknowns, if I can build 2 equations, I can solve simultaneously for those 2 unknowns. So I'm just going to write myself a note here. I'm going to solve simultaneously for b and c. Okay, now if I'm solving for 2 unknowns, I need 2 equations. So what's my first equation I'm going to say? I'm going to say, well, T1 equals 5. So that means that when n is 1, Tn is 5. So 5 would be equal to 3 times 1 squared plus b times 1 plus c. So if I neaten that up, I say 5 is equal to 3 plus b plus c. Okay, and you know lots of terms. What's term number 2? Term number 2 is 9. So 9 is the value of the term when n is 2. So 2 squared plus b times 2 plus c. So 9 is the value of the term, and that would be 12 plus 2b plus c. So what I've done here is I've created 2 equations using T1 and T2. So this is equation number 1 and equation number 2. And now all I need to do is solve simultaneously, which is something you've been doing for years now. So a little bit more complicated because you have to set up both of those equations. But it's actually quite easy to solve these simultaneously, simply because, I don't know if you remember the elimination method. The idea is I'm allowed to add and subtract equations to each other. So if I write these down under each other, I can subtract. Now, why do I want to subtract? Because you'll notice that there's a c and a c. So if I subtract this entire equation, c take away c, will disappear. So 9 take away 5 is 4. 12 take away 3 is 9. 2b take away b is b. So this is definitely a far easier way to do it other than the traditional simultaneous of isolating a variable, substituting, all those things. Subtracting, this is called the elimination method. If it's not something you're comfortable with, you absolutely can solve it the more traditional way. Now if I subtract 9 on both sides, what do you know? I get b is minus 5, which I know is the right answer. So now all we have to do is find c. Now that's not a problem because there is an equation involving b and c, and there is an equation involving b and c. I would go to the green one because it's just easier. So now I would say 5 equals 3 plus b plus c, which would mean that if I solve for c, I get 7, which I know is the right answer. So again, I get exactly the same formula, 3n squared minus 5n plus 7. Now you notice this is definitely longer and definitely more complicated. So all of the examples from here on out, I'm going to use the first method because, as I say, 99% of questions that you ever see, you can use your first method. So example 4. Let's use the cheat method. Consider the quadratic equation -5, -15, -29, -47. Determine a formula for the general term Tn. Even if I didn't know it was quadratic, I would check my differences. So -5 to -15, this is actually I'm minusing 10, then I'm minusing 14, and then I'm minusing 18. So definitely not linear. Second differences, I'm minusing 4, and I'm minusing 4. Oh, now I write plus. Just be careful with negative differences. Often we get really confused. If you ever are confused, don't forget you go, that one minus the guy before gets me the difference. So let's do our 3 steps. Step number 1 is our second difference equals 2a. So -4 equals 2a, divide by 2, and I get -2. Second step, my first difference is equal to 3a plus b. So 3a plus b is going to equal to -10, but I know a is -2, so that will give me an equation with only b, so -6 plus b equals -10. If I add 6 to both sides, I get -4. And my last step is that a plus b plus c gives me my first term. So a plus b plus c will give me this -5. I know that a is -2. I know that b is -4. And I don't know c. So that is now -6 plus c is -5. If I add 6 to both sides, I get +1. And there we go. So definitely much easier than the other method. And so hopefully this one makes sense to you and it's the one you choose to use just because it makes your life easier. So my formula, don't forget to answer the question, is -2n squared minus 4n plus 1. Just don't, lots of people tend to write x's here because we're so used to writing x's. Just don't forget that it's n. Now again, I would just throw in n as 1 and check. So if I put an n as 1 into n, do I get out? I get -2, minus 4 is -6, plus 1 is -5. Then I'd put in 2 and just check if you got out -15. Now I went and checked mine on my calculator and I did get -15, and so I know I'm right, which is quite nice. Okay, let's have a look at our last example. Consider the sequence 2, 3, 6, 11. Determine the general term of the sequence. So this is a good question because it doesn't tell me if it's quadratic or linear, or maybe it's something funny. So let's have a look. What's my first differences? This is 1, 3, 5. My second difference is 2. So now I know this quadratic. So we should be getting quite good at this now. My second difference, first step, my second difference is 2a. So in this case, a is 1. Second step, my first difference is 3a plus b. So 3a plus b will have to equal 1. So 3 times 1 plus b will have to equal 1. And b is equal to -2. And my last step is that a plus b plus c has to equal my first term. So in this case, a plus b plus c equals 2. So 1 plus negative 2 plus c equals 2. So that's minus 1 plus c is 2. So if I add 1 to both sides, I get 3. And this is generally a 4-mark question, so you do actually have quite a bit of time for it. So I actually get 1n squared, which I could just write as n squared, minus 2n plus 3. Again, I would check. I would sub in n as 1 and check. Do I get out 2? Sub in n as 2. Do I get out 3? And I check that in my head, and I do. So I think I'm right. So how I'm going to extend us in this question is what happens if we say which term equals 1638. Now when it says which term equals this is the value of the term. So this isn't n. They're not saying position 1683. They're saying the value of the term is 1683. So what they're telling me is that Tn is 1683. So therefore I know that Tn at the moment is n squared minus 2n plus 3, and they're telling me that the value of the term they're interested in is 1683. Can I find what position that term is? As in, can I solve for n? Now this is a quadratic equation. We've been in quadratic equations for ages. So I make one side equal to 0. So I take my 1683 over to the other side, and I get minus 1680. Now I have absolutely no idea what factors multiply together to give me 1680. And so I would definitely use my quadratic formula. So it's negative b plus minus the square root of b squared minus 4ac all over 2a. Now you don't have to show me any working other than that. You must show me substitution into the formula, but after that you don't have to show anything. Now if I get values for n that are negative or fractions, I know they can't possibly work. So what do I get? I used my calculator and I got n equals 42 or n equals minus 40. Now you can't possibly have a term in the negative 40th position. So my position cannot be negative. So if I land up with negatives or if I land up with fractions, that couldn't have possibly worked if 1683 is actually a term in the sequence. But this question said which term is equal to, so it's told me it's a term in the sequence. So therefore, it's term number 42. And so one of these answers will all be one that you crossed out. If you got both of them negative or both of them fractions, then you know you've made a mistake, because this is a term in the sequence, and so you have to get one answer that makes sense. Right, so that concludes our introduction and our basic idea of a quadratic pattern. I'm hoping that you like the first method and it makes sense to you. And there are 4 quick questions that we're going to do from the textbook, exercise 3.3 and exercise 3.4. Probably won't take you long. Please ask questions if you need to, because this is our basic grade 11 concept, and we're going to move on to more complex ways of using this in the next lesson. So please ask questions whenever you have a problem. Well done, guys.